You know, for as long as humans have existed, dreams have been this deep, profound mystery, a private universe we slip into every single night, only for it to vanish the moment we wake up. But what if we could do more than just be a tourist there? What if we could actually knock on the door and get an answer? Well, believe it or not, science is finally starting to pick the lock on the dream world. And what we're finding inside is, well, it's more incredible than we ever imagined.
And that right there is the big question, isn't it? This is the fundamental problem that's kept dream research kinda in the dark for centuries. I mean, the whole experience is completely subjective. How on earth do you measure something you can't see or touch or hear? How do you get any kind of objective data from a world that, by its very definition, exists only inside someone else's head?
For the longest time, scientists were totally stuck on step one, just figuring out for sure if someone is dreaming, simply by looking at their brainwaves. It sounds easy, right? But if you don't have a clear signal, you're basically just flying blind. And for decades, that's pretty much all anyone could do.
And this is exactly why it was so difficult. Just look at this. When we're in REM sleep, that's when we have our most vivid dreams, our brain's electrical activity is so wild, so chaotic and complex, that it looks almost identical to the brain activity of someone who is wide awake. For decades, the only real clue doctors had was watching for those rapid eye movements. The dream state was, for all intents and purposes, a completely locked room.
A huge portion of this brain signal was just written off. It was dismissed as background static, something called 1/f noise. Everybody just figured, that's just the hum of the machine, it's meaningless. But thankfully, a team over at UC Berkeley decided, you know what, let's listen a little closer to that static.
And what they found was a total game changer. Buried deep inside all of that so-called noise was a unique signature. Specifically, they found a much faster drop-off in high-frequency brain activity. And this little drop-off is a clear, universal marker that basically screams, yep, this person is in REM sleep, they are dreaming right now. The locked room finally had a key.
Okay, so now we can actually identify a dream as it's happening. The next logical question is, what are they for? The most popular theory, the one you always hear, is that our dreams are there to help us solve our waking life problems. It's a really nice idea, but when you actually start looking at the data, the whole thing begins to fall apart.
So this is the idea, right? That our brain is like this supercomputer that runs simulations all night long to find brilliant solutions to our problems. But if that were their main job, you'd expect a couple of things to be true, wouldn't you?
For starters, you'd probably expect us to remember the solutions, right? I mean, what's the point otherwise? But researcher G. William Domhoff points out that we recall less than 1% of our dreams. That is a terrible delivery system if the whole point is to give us some kind of waking insight.
And then there's this. Even in that tiny, tiny fraction of dreams we do remember, studies show that only about half of them have any connection at all to what we were doing or worrying about the day before. The rest seem to come completely out of left field.
And this, right here, this gets to the most crucial point. In one study, they presented dreamers with problems they were trying to solve. One person, who was worried about a medical issue, dreamt that her doctor gave her a diagnosis. But it's her reaction after she woke up that's so telling. The dream itself didn't offer a solution, it just acted out her anxiety. The actual aha moment, the real problem solving, happened when she was awake, thinking about the dream.
So, if dreams aren't our personal problem solvers, then what are they doing? Well, there's a ton of growing evidence for another critical function: consolidating our memories. You can think of your brain like a library that's taking in new books all day long. And at night, a librarian has to come in, sort through everything, figure out what's important, and file it all away in the right place.
And the heroes of this story seem to be a special class of cells called adult-born neurons, or ABNs. These are brand new neurons in the hippocampus, which is basically memory headquarters in the brain. And because they're so new, they're super flexible and perfectly designed to help us form new memories.
An absolutely brilliant study from Japan showed this in action. First, researchers tagged the specific ABNs that fired up when mice learned a new task. Then, when the mice went into REM sleep, they saw those exact same neurons light up all over again. The brain was literally replaying the memory. But here's the kicker. When they used light to shut down those specific neurons during sleep, the mice's memory of the task got worse. This is a direct causal link. That activity during our dreams is absolutely essential for locking in our memories.
So we've gone from being able to spot a dream to understanding one of its most important jobs.
But the most mind-bending breakthrough, the part that sounds like science fiction, is that we might not have to wait until someone wakes up to ask them what their dream was about.
I mean, really think about that. Could you have a conversation with someone who is fast asleep and dreaming? The whole idea of interactive dreaming, where an experimenter and a dreamer can actually communicate in real time, well, it's not science fiction anymore. It's really happening.
This is real data from a study done by 4 independent labs around the world. While a person was confirmed to be in deep REM sleep, an experimenter asked out loud, "What is 8 minus 6?" The dreamer, still completely asleep, answered by moving their eyes left-right, then left-right again, the pre-arranged signal for the number 2. Correct. Another dreamer was asked if he spoke Spanish. He didn't, and he answered no by correctly contracting his facial muscles twice. This is real-time two-way communication with someone inside a dream. It's just incredible.
So you have to be wondering, how is this even possible? How did they perceive the questions? Well, the reports from the participants are just fascinating. For some, it was like the experimenter's voice was a movie narrator speaking over their dream. For others, the questions were woven seamlessly into the dream itself, like hearing the question come from a car radio inside the dream.
And this quote from one of the dreamers, wow, it really gives you a sense of just how profound and strange this experience must have been. Imagine you're in a fully immersive world, and suddenly you hear a voice coming from outside of that reality talking to you.
Now, we've got to be realistic here. This is not some perfect, crystal-clear telephone line to the dream world. As you can see, the most common result was just no response. But on about 18% of the attempts, they got a correct answer, and that's far more often than they got an incorrect one. The point isn't that it works every time. The point is that it works at all. That fact alone completely shatters our old ideas about what's possible during sleep. So think about the journey we've just been on. We went from seeing dreams as just meaningless noise to finding their unique signature in the brain. We went from thinking they were for problem solving to seeing their vital role in making memories. And finally, to actually having a real-time conversation with someone inside their own dream. This research opens up a completely new way to explore consciousness itself. The door to the dream world is officially open. So I'll leave you with this. What's the first question you would ask?